Hello, dear students. This is problem number 12 of chapter 4 of Engineering Mechanics Statics, 9th edition. So, in this problem, this is a truss which we have to find out the forces in member EF, DE, DF, CD, and FG. Okay, so first of all, we read a question. A drawbridge is being raised by a cable EI. Let's say it is a cable which is force acting on it FEI. Okay, the four joint loading is shown result from the weight of the roadway. Okay, this is four loaded, which is loaded at point 4. This bridge 4 points. Okay, uh, 2 keeps, 4 keeps, 4 keeps, and 2 keeps. So first of all, we need to draw a free body diagram because there is more than two forces which is acting on uh, a joint, uh, more than two unknown forces which is acting on a joint. If there is more than two unknown forces, first of all we draw a free body diagram of the whole truss, and then we have to find the reaction forces, which is it is a hinge support. Therefore it will resist two type of forces, horizontal force and vertical force. Okay, so first of all we need to find the reaction forces. So I draw a free body diagram like this. Okay, in this it is AX force, reaction force AX, and reaction force AY. Okay, and it is also a reaction force which is FEI. So there are three equilibrium equation, which is summation of all vertical forces in this equal to 0, and summation of all horizontal forces in this truss equal to 0, and summation of all moments at a fixed point equal to 0. So first of all, summation of all horizontal forces equal to 0. So F of AX, this is the horizontal force in this whole truss, and the other horizontal force is the component of this FEI is negative FEI. If you resolve it into its components, so uh, one uh, one component of this is F force in EI in cable. EI cos 30 degree because it is cos 30 degree, that is because of 20 degrees raise at here. If you draw a horizontal axis of this is the horizontal axis and this is vertical axis. So this is 20 degree, which is the horizontal, which is cancelled with this angle. So the remaining 30 degree will it raise. So from the horizontal axis, from point this and the horizontal axis, this cable raise at a degree of 30 degree. Okay, because of not 50 degree, because 20 degree ahead and 20 degree ahead, this will cancel out and the 30 degree will remain up from this horizontal axis. So this is cos 30 degree equal to 0, and the second equation is summation of all vertical forces equal to 0. So FAY, which is this vertical force, and the other vertical force is negative 12, which is this force, and this 2 plus 4 equal to 6 plus 4, 10 equal to 2 plus 2, 10 plus 2 equal to 12, negative 12, because this all force is directed downward, uh, plus one vertical component of this force FEI. So FEI sine 30 degree equal to 0. Now the third equation of equilibrium equation equal to summation of all moment at a fixed point A point equal to 0. So 4 into 10 cos 20, this is 4, keep into the horizontal distance is 10. 4 into this is the horizontal distance is 10. 4 into 10 cos 20 degree. Okay, and also negative 4 because it make clockwise. We call make clockwise will negative and counterclockwise will taken as positive. So 4 into 20 cos 20 degree, which is this 10 feet plus 10 feet. It is uh, 10 20 feet away from here. So 4 into distance is 20. So 4 into 20 cos 20 degree because it raised by 20 degree from x-axis. That's why we will move it to the horizontal axis. So that's why we take only cos component, because the movement is start from the horizontal. Okay, that's why we take here cos 20. Negative 2 into 30. So this is 2 into distance. Moment equal to RF. R mean radius or distance. F mean force. So 30 is away from here. From A to keep is 30 feet away from point A into 2. So 2 into 30 cos 20 degree plus, which is this FEI cos 50 degree. It makes an angle with the x-axis is 50 degree. The whole angle with x-axis is for 50 degree. 20 degrees here with x-axis and 20 degrees up from the x-axis. So the whole angle makes of 50 degree. And also mm, 30 into FEI sine 50 degree, and it's I take its horizontal vertical component. Okay, so FEI 30 sine 50 and 8 cos of 50. Okay, this is 8 force. From here is this force is away 8 feet vertically from point A. So 8 into force. Okay, force FEI cos 50 sine 50 degree. So equal to cos 20 into I common cos 20 from here. Okay, I common from this cos 20 degree. So cos 20 into 40 plus 80 plus 60. 4 tens are 40, 4 20s are 80, 4 30s are 60. So cos 20 equal to 180 divided by sine 50 divided by 30 sine 50 plus 8 cos 50 degree. So when you calculate it on calculator, so the result will come FEI will equal to 6.01 kips. Okay, once you find this FEI, you can easily find FAX and FAY. So if the second from the second equilibrium equation, Fx, so Fay equal to 12 negative, this is from the second equilibrium equation, Fay minus 12 negative 12. When you move it to the right side, it will become positive 12 plus, and when you move FEI sine 30 to the right side, it will negative FEI sine 30. So 12 minus 6.0, this is the value of FEI gives sine 30. Okay, so if you calculate this whole on calculator, so the result will come 8.995 gives. Similarly, FAX is equal to FEI cos 30. So FAX will, and at the place of FEI there is 6.01 cos 30 degree. This is cos 30 degree, and FAX equal to 5.205 gives. Okay, so now I check joint to calculate the required force in the members. So first of all, I want to take joint E because there is two unknown forces and one known force. Okay, so summation of F of all horizontal force is equal to 0. So negative F E F negative F E F negative F E I cos 50. This makes an angle with x-axis is equal to 50 degrees. So cos 50 degree equal to 0. So negative F equal to FEI cos 50 degree. So at the place of FEI there is 6.01 cos 50 degree. So FEI will equal to negative 3.80 keeps. Okay, this is in compression. I was assumed that it is in tension, but it is not in tension because of because of negative sign. It is in compression. So summation of all vertical force is equal to 0. So one vertical force is this, one vertical force will be the component of this member force. Okay, so negative FED, which is FED, negative FED downward will be taken as negative FED plus FEI sine one vertical force of this one vertical component of this force. So plus FEI sine 50 degree. So FED will equal to negative FEI sine 50 degree. If you calculate it on calculator, so the result will come 4.604 kips, which is in tension because the answer come with a positive sign. Now I want to take giant D here. I want to take giant D. So this is giant D, which is 4 forces acting on it. Okay, so first of all I assume that these all forces are in tension, and then I resolve this force into its component. So FDF so cos 38 point, this is the horizontal component cos component, and this is a sine component of this force. So I resolve it into its component. So this angle is 70 degree. How I find this angle? I find this angle like I draw. Uh, if you draw a triangle with this truss like this is 20 degree with the horizontal axis. Like you can see here, this is 20 degree with the x-axis. So 20 degree, and this is perpendicular, this force is perpendicular to this horizontal axis, so it will be 90 degree, 20 degree, 90 degree, and this will not we can't this is not found to us. So there is 180 degree in a triangle. Okay, alpha plus beta plus gamma, there is 120 degree in a triangle. So let's say alpha is 90 degree and beta is 20 degree, and the gamma is not found to us. So uh, gamma will equal to 180 degree minus 90 degree minus 20 degree. So gamma will comes out 70 degree. So this is 70 degree. This angle with the horizontal axis, it is 70 degree. So the horizontal component of uh, this load is 2 sine 90 and 2 cos 90. Sorry, 2 sine 70, it is 70 degree, and 2 cos 70 degree. This is its horizontal component, which is parallel to this, and this is its vertical component, which is parallel to this. Okay, so summation of f of y equal to 0. FDE uh, which is this force, and plus FDF sine 38, which is this force, and negative this force 2, which is this component of load 2. Negative 2 cos 70, negative 2 cos 70 equal to 0. So how I find this angle? You can find this angle by tangent theta, like you can see here. So this is, you can find this angle. This is, for example, theta. So tangent theta equal to opposite. Opposite is here, and this is 8 feet. So opposite divided by adjacent side. Adjacent side is 10 feet. So theta will equal to tangent inverse 8 divided by 5, 8 divided by 10. So theta will equal to 38.65 degree. Okay. So I find this 38 degree, like from the tangent formula. Okay. So if you find FDF will equal to 2.2 sine 70 negative FDE divided by sine 38.65. So FDF will equal to, at the place of FDE, this is fine to us. So at the place of FDE there is 4.604, which is we find earlier it. So if you calculate this on calculator, the answer will come 4.36. Negative sign means that my assumption was wrong. It is not in tension, it is in compression. DF is in compression. So this is FDF, it is in compression. Okay. Now summation of all horizontal forces equal to 0. Negative FDC, negative FDF cos 38 point. So negative FDC is this force which is directed toward left. That's why I put here negative, and FDF, which is this force component of this FDF, which is directed toward it, also directed toward negative left. I put here negative sign. Okay. So cos 38.65 negative 2 sine 70 equal to 0. So negative FDC will equal to, at the place of the FDF there is negative F 4.36 cos 38.65. Okay. Plus 2 sine 70 degree. Okay. So if you calculate it on calculator, the answer will come 1.5 gives, which is the answer come with a positive sign. It means that my assumption was right. It is in tension. Now I select joint F to find the required force in member. Okay. So joint F, in joint F there is 4 forces acting on joint 4, and first of all I assume that these all forces are in tension. If the answer come with a positive sign, it means that my assumption is right. If the answer will come with a negative sign, it means that my assumption was wrong. It is in tension. Okay. So first of all I want to resolve it into its components. So first it is the horizontal force, and the it is the resultant force. The horizontal component of this force is FDF cos 38.65, and the vertical component FDF sin 38.65. Okay. Now I want to take summation of all horizontal forces in x-axis. Horizontal force is equal to 0. So negative, this is FGF, negative FGF plus FEF, which is FEF, positive FEF, and plus FDF, the horizontal component of this FDF. So FDF cos 38.65, so cos 38.65 equal to 0. I want to find this force, force in member GF. So negative, I move it to the right side, this all value to the right side, because this is known to us. So negative FEF, negative FDF cos 38.65. So FGF will equal to negative into negative 38.6, 3.86, negative into negative 4.6. If you solve this on your calculator, so the result will comes out FGF will equal to 4 7.28 keeps the positive sign show that it is in tension. So we find all the required forces in the member, which is FGF. I I find out which is required, was required in question. FDC also was required in question, and FDE also was required in question. This is also required. This was also required in question. Okay. Thank you very much.